Tonight, if the sky is clear, walk outside and look up. What you'll see is about 2,500 stars with your naked eye. That sounds like a lot, until you realize that's roughly 0.01% of the stars in our galaxy alone. The Milky Way contains somewhere between 100 and 400 billion stars, and the Milky Way is just one galaxy out of an estimated 2 trillion galaxies in the observable universe. The numbers get so large so quickly that the human mind genuinely cannot process them. There are more stars in the universe than there are grains of sand on every beach on Earth combined, multiplied by 10,000, and around most of those stars, planets orbit. Some of those planets sit in the perfect zone for liquid water. Some of them have existed for billions of years longer than Earth. The math seems impossibly clear. The universe should be teeming with life. It should be loud. It should be obvious. So where is everyone? This is the question that has haunted scientists for over 70 years. It has no easy answer, and the possibilities are some of the most disturbing ideas humanity has ever encountered. Let's start with the man who first asked the question, because the story of the Fermi paradox begins in the most ordinary place imaginable, a cafeteria. In the summer of 1950, at the Los Alamos National Laboratory in New Mexico, 4 physicists sat down for lunch. One of them was Enrico Fermi, the man who built the world's first nuclear reactor and one of the greatest scientific minds of the 20th century. The conversation wandered, as lunch conversations do, from a recent newspaper cartoon about flying saucers to the possibility of faster-than-light travel. The other physicists moved on to other topics, but Fermi went quiet. He was thinking. He was doing calculations in his head. And then, out of nowhere, he looked up at his colleagues and asked a question that would echo through science for the rest of human history. But where is everybody? He didn't need to explain what he meant. His colleagues understood immediately. Fermi had just done the math. He had calculated how many stars exist in the galaxy. How many of them likely have planets? How many of those planets could support life? How long it would take a single technological civilization to spread across the entire galaxy, even at speeds far below the speed of light? And the answer he came to was staggering. The galaxy should already be colonized by someone many times over. Here's the math that haunted Fermi. The Milky Way is roughly 100,000 light-years across. That sounds enormous, and it is. But the galaxy is also 13.6 billion years old. If a single civilization, anywhere in the galaxy, developed the ability to travel between stars at even 1% of the speed of light, they could colonize every single solar system in the Milky Way in about 10 million years. That sounds like a long time, but compared to the age of the galaxy, 10 million years is nothing. It's less than 1/10 of the galaxy's lifetime. Scientists have proposed dozens of possible answers, and each one is unsettling in its own way. Let's walk through the most serious possibilities, because each one tells us something different about our place in the cosmos. The first possibility is the simplest, and maybe the most disturbing. We are alone, truly, completely alone. Life on Earth may have been an accident so improbable that it never happened anywhere else. The transition from non-living chemistry to living biology may require a chain of events so unlikely that even with trillions of planets and billions of years, it only happened once. If this is true, then humanity is not just rare. We are unique. We are the universe waking up and looking at itself for the first time. The second possibility is gentler, but still strange. Life is common, but intelligent life is extraordinarily rare. Earth has had life for around 3.8 billion years, but for most of that time, life was nothing more than single-celled organisms drifting in the oceans. Multicellular life only emerged around 600 million years ago. Complex animals only came later. Humans only appeared in the last 300,000 years. Civilization only began around 10,000 years ago. Radio technology only emerged in the last 130 years. So even on a planet perfectly suited for life, intelligence took almost the entire history of the planet to develop. The third possibility is even stranger, the dark forest hypothesis, popularized by Chinese science fiction author Liu Cixin. The idea is that the universe is a dark forest, and every civilization in it is an armed hunter, moving silently through the trees. To reveal your location is to die. because you cannot know the intentions of other civilizations, and because the risks of contact are catastrophic, the only rational strategy is to remain silent and destroy any other civilization that reveals itself. And then there is the possibility that touches on something deeper than science. Each of these explanations is a window into a different possible universe. And the truth is, we don't know which one is correct. We may never know. The Fermi paradox is not a problem with a solution. It's a problem that forces us to confront our place in the cosmos with absolute honesty. But there is one thing the Fermi paradox does tell us with certainty. For now, all we have is the night sky, trillions of stars, trillions of possibilities, trillions of stories that may have already ended or may not yet have begun. We are a single species, on a single planet, in a single galaxy, asking the largest question that can possibly be asked. And the universe, for now, gives us no answer. So tonight, look up, see the stars, feel the weight of the silence, and remember that you are part of one of the deepest mysteries in all of existence. The question is not just whether anyone else is out there. The question is what we will do with the fact that, as far as we know, we are here.